Okay, hi and welcome to video notes 8.3, 8.5. So we're going to mix up some properties here of exponents and we're going to go through them with you. And you can see a couple of examples of how they're going to look. So let's get right down to it. This is day one. We'll hit this again with another day and review these and hit some new ones. But for today, here are our properties. The first one we like to call is multiplying like bases. Okay, so that means that if we have the same base, being A has to be the same base, exactly the same base. But if that's true when we multiply them, what the result is that the base stays the same. Nothing changes there. We don't add or multiply or subtract it, but our exponents are added. Okay, and we'll see some examples of these in just a second. So here's the next one to compare and contrast that with, is that this is what we refer to as a power to a power. What does that really mean? Well, it means that I have a base raised to a power raised to another power. So a power to a power, hence the name. What happens in that scenario, if you've got some base raised to an exponent and raised to another exponent, you're going to multiply your exponents. Okay? All right, so the next one then is what we call power of a product. What that means is that you've got a couple different bases inside, and then they're all raised to some other power. So this would be some type of a term, some term inside, and that's raised to some power. Every part of the term that's multiplied or divided that's inside these parentheses will be given that exponent that it's raised to. So you can kind of think of this in some sense as of a distributive property of an exponent. It's not the distributive property, entirely not the distributive property, but it's like, and I want to put that on there because there's a point coming up in the next semester where we'll talk about this explicitly, that it's not the distributive property. So, but it's the easiest way to kind of comment on it now. So we'll hold off on that note for a little later. And then of course, so we've got the negative exponent, which means to move positions. That's a review from other notes that we did before. All right, so now that we've got our rules down, let's see them in action, because there's not a lot to talk about outside of seeing how they work. So here we go. We're going to go ahead and talk about multiplying like bases. 11 is the like base in this scenario. The exponent is 4 and 3, and we've learned that we take the same base and we add the exponents. So it'll be 11 as the base raised to the power of 4 plus 3, or to the 7th power. Pretty simple, pretty basic here. All right, well, you can see some other examples here, same thing. Go ahead and take a look at those. But at number 4 here, you'll notice that we also have a coefficient. So let's take a second to break this down. What does this really mean? Well, all of these are multiplied together. So it's 2 times n to the 5th times 3 times n to the negative 2. And you're like, hold up, Mr. Hallam, I've got a negative exponent there. What do I do with it? Well, let's pause for a second because we might be able to take care of it with a different rule before we move it. So this is what it actually breaks up to be. So what we're going to do is we're going to put the 3 and the 2 by each other because multiplication is commutative, meaning we can rearrange it. And this is what we'll get. We're going to get 2 times, it's going to be equal to 6, 2 times 3 next to each other, and then we're going to put the n's next to each other. Why am I doing this? So you can see what's going to happen. So now that I've rearranged it, we're ready to do the next step. Just on a note, you won't have to do the rearranging step. Most of us do that in our heads, and I'm fine with that. So 2 times 3 is 6, so you can see where 6 comes from. And this n to the 5th, n to the 5th and n to the negative 2, well, instead of moving this n, let's use this multiplying like bases, because it's a like base, right? And we multiply like bases, we add them. So let's go ahead and add those. So what we get is 6n to the 5 plus a negative 2, or subtract 2, which is going to result in 6n cubed. So instead of moving it, we went ahead and used a different property to combine it, and it ends up positive and in the spot that it's fine. So that's what you're going to find with these exponent rules, is that they're going to overlap. And one's going to be better than the other because it's less steps. That's all it is. Doesn't mean that the other one's wrong. No, go ahead and do it. You just might do an extra step. So it doesn't matter which way you go. If you moved it, that's fine. You don't technically have the rule to deal with it if you moved it right now, but after tomorrow's notes, you will. So in this scenario, don't worry that you don't do it like your neighbor. As long as you're doing it correctly and end up with the right result, you're fine. They can go in other directions. Not everybody's going to do these exponents the same. All right, so let's talk about some other like terms, or like terms and non-like terms. You can see here we've got a c to the 4th, a d to the negative 3rd, and we've got a c squared. So we've got 2 like terms and 1 non-like term. Here's what we're going to do. we're going to put the like terms together, and if they're multiplied, we know that we add exponents, so I'm going to have 4 plus a 2, right? And then D is just along for the ride. It's got a -3 that we're going to deal with here in a second, so I'm going to circle it, and we're going to move it to the denominator, because that's what that negative is telling us to do. In the numerator, meanwhile, we get c to the 6, because 4 plus 2 is 6, adding our exponents, right? And d is moved to the denominator, and that exponent becomes positive. So that's our result if those two combinations. So now you can see we're working with multiple bases and our properties. So you can see there's a lot of moving parts. Take care to do those kind of one at a time. So you can see here I rearranged this one a little bit. I put all the coefficients together so you can see how that multiplied to 30, and you can see I went ahead and put all the exponents there. Eventually you guys will not do this step. I'd like to see this in your homework though until we get better at it. All right, so let's do this with scientific notation. Okay, so there's our scientific notation. How does that work, Mr. Hallam? They're all numbers. Well, kind of. We'd like to think of this as a base of 10. So I'm kind of treat it kind of like it's this variable here, and I'm going to add its exponents separate of 7 and 4. The 7 and 4 I'm going to think of as coefficients, let's say, because technically it's kind of what they are. So I'm going to move 7 next to the 4, and they're all multiplied here, all nice and fancy. So I'm going to move the 7 and the 4 next to each other, and then I'm going to have that be multiplied, and I'm going to use a different multiplication sign there. Why? To signify scientific notation, right? Because that's this x here, this multiplication sign. So that's what that one represents. And then I'm going to go ahead and, since they're being multiplied and they're like bases, I'm going to go ahead and add their exponents. So 2 plus 5. So if you take a second there, look where everything's moved, right? 7 times 4 is 28. And that's be multiplied by 10, and then these two exponents are going to add together to the 7th. We're really close to being done, except for we are breaking one rule. This has to be between 1 and 10, and it's not. It's 28. So I'm going to move my decimal place once to the left. And remember, if we move it to the left, our exponent should get larger. So it's going to be equal to 2.8, which falls between 1 and 10, times 10, and my exponent then has to be raised to the 8. Hey, not too bad. All right, so let's check our product, or a power to a power rule, which I have a base and an exponent raised to another exponent. And that rule, it was pretty simple. We're going to multiply them. So it'll end up being x to the 3 times 6, or x to the 18th. Okay, there's a little exposure to that. And again, you got some other examples here you can pause and look at if you'd like to. All right, sometimes, this is where I was talking about here, that we have overlapping rules or overlapping ways. We have to do that, but there is something to pay attention to, is that there is an order of operations still. Certain things need to be addressed first. So you might be thinking, hey, look at number 6. I want to take this c to the 5th and this c to the 3rd and put them together and get c to the 8th. Well, that would be wrong, because order of operations says we have to address this exponent here, this -2, actually has to be the first thing that we address. So pay attention to the order of operations. Once you've done that, whatever fashion you take to solve these, as long as it's correct, is fine. So let's go ahead and close down that. So let's go ahead and do this one, looking at it. I'm going to take and use my product, or power to a power rule here. So c to the 5th is going to come along for a ride, and I'm going to end up with it multiplied by c to the 3, I'll put it in parentheses, 3 times -2, and I'll put that all in parentheses. So there's the first step, my first cleaning. See if I can squeeze it in down here. So c to the 5th is going to stay there. These are going to become times c to the -6. Well, now we can combine those. So we're going to use the property here, multiplying like bases, right, where we're going to add exponents. And when I add these exponents, I'm going to end up with c to the 5th plus a -6, or c to the -1. Well, now, guess what that tells me to do? Move its position. So I'm going to end up with 1 as my placeholder in the numerator, because there's the denominator right there, over c. Okay, so there's multiple ways to attack this. You'll see that we could have moved the c to the -6, the denominator here, and then we could have had to deal with that c to the 5th. You don't have that rule yet, but again, tomorrow you will. So you'll have lots of approaches for this, so don't let that confuse you. All right, so this one is a product of a power, so we're going to go ahead and distribute this. Again, kind of distribute this. So in this scenario, we're going to get 2 is raised to the 4th and z to the 4th. I'm guessing you didn't realize the 2 was also going to get raised to the 4th. Guess what happens, this is a common mistake here. This is where students generally miss stuff. They only do it to the variable, not to the number when they do this rule. So make sure that you're doing it to both, or everything inside the parentheses. All right, so that's going to work out to 2 to the 4th, which we've already seen before is 16, right? And then z to the 4th is going to stay the same. Now, number 8 is kind of where most of your action at. This is your main problem. You're going to see that lots of times. So, and there's lots of steps and lots of ways to do with it. Mind your order of operations, and let's clean that up. So the first thing we have to deal with are both of these powers here, raising everything inside the parentheses. So that's the first thing we're going to want to address. So in step 1, I'm going to say x to the negative 4th, because negative 2 times 2 is negative 4. This 3 is going to get, I'm going to use a multiplication sign here, so 3 is going to get to the power of 4, or be raised to the power of 4. X is going to be raised to the power of 4, and y is going to be 2 times 4, or 8. Okay, so we got a lot of moving parts. We got a negative here we can deal with, but let's go ahead and combine our like terms, or our x's here. That's our common base. And if you look at that, when I combine them, I'm multiplying, so they're going to add exponents. So a negative 4 and a positive 4 are going to turn to 0. So I'm going to get x to the 0. This 3 to the 4th is going to turn into 81, so I'm going to leave it right here in the middle. We'll need to move it to the front because it is a coefficient. Numbers go to the front. We'll do that in a minute. And then there's my y to the 8th, which is along for the ride on that step. All right, so let's clean this up. X to the 0 power is 1. 1 times 81 is 81. So that stays 81, and y to the 8th stays that way. All right, so make sure to watch, or at least look at these. Definitely check out these ones without the numbers here. I'm not sure why they're not numbered, but look at these two and watch the rules. They're pretty self-explanatory. Here's what you'll find is it's a new set of rules. Maybe you're familiar with it, maybe you're not, but you're going to like it. And once you get them down, you're going to be quick and you're going to be fast. But be careful of watching your order of operations, and try writing out your steps so you don't do too many in once. That's generally where most students make their mistake. And don't forget, the caret key is how you enter these powers into the calculator if you need to do something like 3 to the 4th. All right, we'll see you in class.